Hello and welcome. We're going to look now at the second part of fundamental particles and forces. We're going to look at baryons and mesons in detail. These are composite particles made up of quarks. Okay, so to remind ourselves, we finished the last video considering we had quark type 1, quark type 2, the electron, and the electron neutrino. We are going to now focus on, in particular, combinations of quark type 1 and quark type 2. So these are quarks, these are leptons. And these are our two classes of fundamental particle. So let's give these things a name. Quark 1 is known as an up quark. Quark 2 is known as a down quark. We'll include an electron and an electron neutrino in our discussion just for now. We'll see where we're going to take this. Now, each of these particles has something we can measure of it. We know I can measure mass of a particle. We can measure its electric charge. There turns out to be several other things we can measure about these particles. Now, I'm going to tabulate what we know about these particles here. And first of all, the electric charge. And I'm going to use a capital Q. Typically, it's a lowercase q, but I've already used that to define a type of quark. Something else we might measure about an object is its baryon number. And this will become, the purpose of this number will become apparent very soon. A third thing we might measure is its lepton number. Now then, these values have been discovered, theorized, experimentally confirmed over time, so we're just going to present them here. The charge on an up quark is plus 2/3. The baryon number is plus 1/3. The lepton number is 0. For a down quark, the electric charge is minus 1/3. The baryon number is still plus 1/3. The lepton number is 0. These are quarks, not leptons, after all. The electron, the charge is minus 1. As we know, a neutrino, the clue is in the name, it's a neutral particle, it has 0 charge. The baryon number of the leptons is 0. The lepton number is 1. So here's a set of details, and now we might ask how we go about putting together the up and the down quark and seeing what comes out. Before we do that, let's just tell ourselves that we have a few rules to apply. In particular, these are conservation rules. All of the electric charge, the baryon number and lepton number are conserved. What do we mean by conserved? The same thing we mean when we say kinetic energy is conserved, or we say that momentum is conserved. So that Q before is equal to Q after. The electric charge, the quantity of the electric charge before will be the same as it is after. Maybe that works better the other way around. The baryon number before will equal the baryon number after. And for the lepton number, the before will equal the after. So 3 simple conservation laws, and they'll help us later on when we come to consider particle interactions and look at some of the interesting things that happen when particles change. But we are going to, at this point, consider discombining these particles. We're not going to discuss interactions just yet, but there's some rules about how we combine these particles together. So we're going to set some more rules. And these are such that only integer values of Q, B, and L are allowed after we've finished playing or constructing different particles. We noted before that Q, B, and L are also conserved. And we mentioned in the last video that quarks, let's use a lowercase q for quarks, these are only found in 2s or 3s, in combinations of 2 together or 3 together, never on their own. Some people think then you might be able to put 5 together and make something up called a pentaquark, but that's for another video at another time. So with these rules in mind, let's consider putting together a particle. Well, shall we start top left, an up quark, U for up. What happens if I have 3 up quarks? First of all, let's consider the lepton number. And the lepton number for an up quark is 0. So 3 times 0 is 0. 0 plus 0 plus 0, 0 overall. The baryon number. The baryon number is plus a third. So that baryon number will be 3 times a third. 1/3 plus 1/3 plus 1/3. That equals 1. That's an integer value, and we want this to be an integer value, so that's all good. What about the charge? Well, the charge on 1 up quark is 2/3, so the charge on 3 up quarks equals plus 2. That's an integer value. That's fine. And indeed, what we've just built for ourselves here is known as a delta double plus, which is a baryon. There are a vast number of baryons, tens of different types of combinations, not least because for these quark types, I've said there's 1 and 2, there are in reality 6 quark types. So quarks 3 to 6, but we don't discuss those at A level. The charm, the top, the bottom, and the strange. But with 3 up quarks, we might make a delta plus plus. We don't consider these as everyday particles because they have a very short lifetimes. Only the neutron and the proton have anything of an appreciable lifetime, so that we might have a chance to experience them in our day-to-day lives. Let's try something a little bit more interesting then, or relevant perhaps. Up, up, down. The lepton number again will be 0, because the lepton number of both the up and the down quark is 0. The baryon number, well, I have 2 ups, that's 2/3 plus 1/3 of a down quark. That will leave me with a baryon number of 1. But what about the charge? For the charge, I have 2 times 2/3 plus minus 1/3. And altogether, that will equal plus 1. So what might we guess has a baryon number of 1 and a charge of plus 1? It is a proton. So a proton is made up of 2 up quarks and 1 down quark. Let's consider something similar perhaps, an up, down, down. The up, down, down has a 0 lepton number. It has a baryon number of 1/3 plus 1/3 plus 1/3, so 1. We've got another baryon here. And for the charge, I have 1 times 2/3 for the up quark, and I add to that 2 times minus 1/3. 2/3 minus 2/3 equals 0. This is a neutral particle with a baryon number of 1. It is a neutron. Now, just considering ups and considering baryons, so adding together 3 variations of all of these charges, Q1, Q2, the up downs, the tops and bottoms, we can make a whole family. And these are added for a broader interest, but these aren't examined. We might have a sigma particle, or a delta particle. Apologies to the Greek speakers, a psi particle, how I would pronounce that one, and an omega particle, and others, and sub-varieties of these as well. there are lots and lots of different particles. And in the 1950s, 30s to 50s, people were starting to get a little bit worried that maybe we didn't know what we were talking about if new particles kept turning up and turning up. It was the quark picture that helped settle things down eventually. Let us consider instead then maybe two quarks added together. So that's, I might consider two ups. The lepton number we know will be 0. The baryon number, however, now for two ups is going to be 2 times 1/3, which is 2/3. And the charge will be 2 times 2/3. This gives you 4/3. This is not an integer. This is not an integer. This is an invalid collection of quarks. And as such, we do not see this in nature. It is forbidden. The alternative might be to have maybe two ups and a down. An up and a down. The alternative might be to have an up and a down. Lepton number 0, but baryon number will be 2/3, and the charge is going to be 1/3. You should be able to work that through. And again, not integers, not valid. So, how could we ever see two particles together? Two quark particles? Well, the secret is we're going to mirror our particles and introduce a new, I'll not say a new class, they're a related set of particles, which are the antiparticles. And an antiparticle has a very fancy science fiction sounding name, but is ultimately just has the electric charge reversed. There's actually not a lot different about them. So we might draw out a table again. So the charge on an anti-up is -2/3. The baryon number is also reversed as -1, and the lepton number is 0 because it's not a lepton, it's a quark. And doing the same trick, reversing the charge and baryon number for the anti-down. There's meant to be an overbar to represent a U with an overbar is an anti-up, and a U without it is the non-anti-up, or just up. An anti-electron has a +1 charge, and that is known as a positron. The neutrino is negative, and they have a -1 for their lepton numbers. So let us consider now a combination of matter and antimatter. I can just set up my paper. Right, so let's try this combination and see what we get. An up and an anti-up. Well, I can see the lepton number is going to be 0. The baryon number is going to be +1/3, and an anti-up -1/3, so that's 0. The charge is going to be +2/3, -2/3, that is equal to 0. These are integer values, this is allowed, and this particle gets the name of a pi0, or a neutral pion particle, to give it its full name. What about its counterpart, a down anti-down? We can see that it has very similar values, and this will also lead to a pi0. There's some complication here around whether the pi0 is made up of an up anti-up or a down anti-down, but you can worry about that later when you go to university. Something that might be slightly more interesting could be an up anti-down, where we have a lepton number of 0, baryon number of plus a third and minus a third, 0, and for a charge now we have plus 2/3 plus 1/3 to give us a charge of 1, and that's allowed, and this is called a pi plus, or a positive pion. We might have an anti-up and down. We can easily guess the lepton and baryon numbers, but now I have an anti-up charge of minus 2/3 plus minus a third. The charge is minus 1, and this is allowed, and this is a pi minus particle. So let's summarize here. I have a set of baryons. I have a neutron, let's write them down here, a neutron, a proton, an anti-neutron, and an antiproton, the baryon number, the charge of 1, 1, minus 1, minus 1, the charge of 0, plus 1, 0, minus 1. I'll let you work out how we make an anti-neutron and an antiproton. These are baryons. Let us consider the two quark particles. Three quark particles are baryons, 2 quark particles are mesons, and we have the pi 0, we have the pi plus, and the pi minus. Baryon number is 0, the electric charge 0, plus 1, and minus 1. So we've played a nice little game here of adding together particles. We've introduced antiparticles, and we can see that we have a set of baryons and a set of mesons that are all formed from quarks. Thank you very much.